Okay, so we've been talking a lot about patterns, linear patterns, changes in geometric patterns, and now we're going to start kind of more formalizing that and talking about the idea of rate of change, which leads into the idea of slope. So we've been talking about these patterns, but now we're formalizing it as numbers. So rate of change, and we've noticed this in tables, we've noticed constant change and things of that, and phrases like that. It's a ratio, though. When we talk about the actual rate of change, we want to write it as a ratio. It describes how much the quantities are changing. So in the tables we've been doing, we've had your XY table, XY table, and we've talked about, okay, as you move from one number to the next, what's the pattern? Maybe it's +1 in the X values. What's the pattern in the Y's? Maybe it's +5. So a ratio just gives you a way to describe the rate of change for the situation overall. So the pattern overall, or in this case we're going to be heading towards lines, the situation you have, and how we describe it so that everybody knows they're talking about the exact same thing. The rate of change, we always say it's the change in the Y value on top and the change in the X value on the bottom. So another way we can write this kind of shorthand is this triangle actually means the change. We can write it as the change in Y over the change in X. So for instance, the table I gave you, even though there's no values in it, the change in Y is 5, the change in X is 1, so the rate of change is 5 itself. So we always simplify the fraction, but as you'll kind of see, simplified fractions good, improper fractions good, mixed numbers not so much. So when we're doing a rate of change, if we want to calculate the rate of change, again, it's the change in Y value over the change in the X value. So if you look, it doesn't really matter what we choose as far as your change, what you choose to look at. So we could look at, for instance, this first situation and then use this third piece of data. So if we wanted to find the change overall, the rate of change, we could say, okay, what's the change in the Y value and what's the change in the X? So how do I figure out the change in the Y value? The actual calculation would be 234 minus 78 to figure out what the change is in between those two values. Same thing for the X's. How do we figure out the change from 2 to 6? We would take 6 minus 2. So 234 minus 78 is 156, and 6 minus 2 is 4. 156 divided by 4, and my off-screen calculator, is 39, or 39 over 1. So the second part of this is to explain what does this actually mean. And in terms of what it means, we need to look at the units. So we need to pay attention to what do the Y units mean and what do the X units mean. So the Y units here mean $39 is the total cost, and the 1 relates to the number of games. So if we're going to relate this as a sentence or as a phrase here, we'd say $39, and remember the division sign, generally we could say this as per. So this is $39 per one game, or $39 per game. So every computer game costs on average $39. This should look pretty familiar because this is, if you look at this value, what is this value we've actually found? It looks a lot like the unit rate. So kind of interpreting that. So rate of change, the rate of change, the unit rate here was $39. So that was me trying. Now pause it and you try. So the table has Y values, has X values. We want to know the change in the Y, so I'm going to choose to go from 48 to 96, but you could use any pair of numbers. The change in the Y value would be 96 minus 48, and the change in the X values would be 6 minus 3. So 96 minus 48 is 48, 6 minus 3 is 3, so the rate of change would be 16, or 16 over 1. And again, if we look at the units to help us explain the meaning, This is the area of the tiled surface in inches squared, and this is the number of tiles. So what does this tell us? For one tile, you end up with 16 inches squared. So 16 inches squared would be the area per tile. So interpreting is also an important part of thinking about rate of change. So we say the word rate of change. From a table, it's easy to interpret it as just the change amount. The other word we want to use for it, and when we talk about looking at a graph now, this graph shows the number of people who visited U.S. theme parks in recent years, and the word recent is obviously loosely used here because 2006 wasn't so recent. But the other word that we can use to talk about rate of change, and this goes into how are different rates of change shown on the graph, they're shown by different slopes. The word slope means how steep, and we'll look at that in just a second, but how steep the line is. So these different variations in how steep the line is talking about the different rates of change. So if we look at, what could you say about the years 2004 to 2006 compared to 2002 to 2004? Well, that steeper line means there's a much greater rate of change. The rate of change was higher, and here the rate of change was lower. So the steepness of the line is telling us about the pattern. What's the value that the change, what value is the change taking? So again, that word slope, it's used to describe the steepness of a line, whether it's nearly vertical or more towards horizontal. And when I see the word slope, the natural thing to suggest to think about ski slope, maybe a bunny hill versus a black diamond. The steepness of the line is what determines the slope. So when we look at slope, very much, rate of change is a word that you can use interchangeably here. When we do talk about slope, we talk about still change in y value over change in x values, but the change in y values refers to this idea of, and we'll call it rise. The change in the x value refers to the word we use, run. And if you think about rise, rise could mean up, but it could mean down. And run, when we're talking about slope, means movement from left to right. So when we're talking about moving from point to point, or from one point on a line to another point on a line, we use these words to help us find a value for slope. So there are multiple ways to calculate slope. One of those ways is just using this visual representation. So in this case, like if you counted 1, 2, 3, 4, 5, your rise value is 5, your run value is 1, 2, 3, 4, 5, 6, 7, your run value is 7, so your slope is 5/7. Important things to keep in mind about rise values is when you're moving up, and this is not any different than what you see in the coordinate plane in general, you want to use a positive value. So I moved from this point, I was moving up 5, so I used a positive value. If you're moving down, you want to consider that to be a negative value. So if you think about the XY plane anyway, up is positive, down is negative. When you're looking at run, similarly, if you're moving to the right, it's a positive number. If you're moving to the left, it's a negative number. So we'll see that more with some examples coming up, but just to keep in mind. So slope is rise over run, and I listed it as the change in the y value, change in x. So you think rise goes with the y's, rise over run. So we say rise over run is normally how we say this. Whoops. Can't write. Rise over run. Change in y value over change in x. There is also a way that you can calculate this. So when we say change in y, think back how we did rate of change on those first two examples. Rate of change, we did subtracting. And so what you will see, this is actually called the slope formula. So when you have 2 points, and anytime I'm looking for a slope, I need 2 points in some manner. If you have 2 points, and you notice these little numbers, x sub 1, x, or y sub 1, x sub 2, y sub 2, that just tells you this is on point 1, this is point number 2. And it doesn't matter which point is 1 or 2. The way to find the change, so if I think the change in the y's, it involves subtracting those y values, and the change in the x's would be subtracting those x values. The key thing to keep in mind, order matters. So notice how it's y2 minus y1, x2 minus x1. You have to keep that same order. So moving from point 2 to point 1. So if we look at this example, we can count. And I lost count. 1, 2, 3, 4, 5. 5, and I was going upward, so that would be positive 5 as far as my rise goes. And then 1, 2, 3, that's to the right 3, so it's plus 3. So the slope here, and actually I'm going to write it over here, the slope is the rise value over the run value, so that would be 5 over 3. The slope, if we calculated it, we need the 2 points. So first point here I'm going to say is 2 comma 3. Second point here is negative 1 comma negative 2. So 1 and 2. Again, if I calculate the slope as y2 minus y1 over x2 minus x1, we get 3 minus, negative 2 minus 3 over negative 1 minus 2, which is negative 5 over negative 3, which 2 negatives make a positive, so it's still 5 over 3. Either way, you still get the same answer. So if we're trying to find the slope, and I do this one, we're trying to find the slope, 1, negative 4, and 3, comma 4. You can either count, so a line would go through these 2 points. You can either count. So if I counted, I'll go from the other way. I'll go from this point at the top. If I count 1, 2, 3, 4, 5, 6, 7, 8. I moved down 8, and then I moved left 2. My slope would be my rise value over my run value, which is positive 4. If I did the calculation, and I said this is point 1, this is point 2. I take my slope, or take my y values, y2 minus y1 over x2 minus x1. 4 minus negative 4 is 8, 3 minus 1 is 2, and my slope still ends up being 4. Either way, you need to find what works for you. But probably be aware of both methods, just find which one you prefer. So we're going to end with you trying this slope problem. So pause it, try it, and then review here. 3, negative 1, negative 5, 3. If I'm counting, and there's my 2 points. I'm counting. I'm going down 1, 2, 3, 4. So that's minus 4. And then I'm going to the right 1, 2, 3, 4, 5, 6, 7, 8. So I went to the right, so that makes this a positive 8. So the slope would be, the rise was negative 4, the run was 8, so the slope would be negative 1/2. If we do the calculation, and I say this is point 1, and this is point 2, y2 minus y1 over x2 minus x1 is 4 over negative 8, which is still negative 1/2. So we'll review slope tomorrow and continue practicing it along the way.